I'm very glad to be here for our second in-person meeting back. Welcome also to all of you watching live. We are streaming to YouTube. Hopefully you're not experiencing technical difficulties. If you are, post them in the chat on YouTube. We'll figure it out. Please bear with us. First time, hopefully, having everything working. So before we jump into tonight's talks and why you're all here, a few updates, a few notes. First, we have a code of conduct at ChiPy. This applies to everybody here in person, everybody online, everyone who engages with our community. If you go to chipy.org/pages/conduct, you can find out more. We take it seriously, but as long as everybody's cool and respectful, I think we'll get along just fine. We are here today not just because of organizers and our speakers, but because we have fantastic sponsors. Of course, we are here today at SpotHero, who provided all of the food you're eating, the venue that you're in. So if we give them a big round of applause. And to tell you a little bit more about SpotHero, I have Sivji here. See you.
Thank you all for attending this month's ChiPy event, whether you are here physically or on YouTube. We appreciate all of you. Thank you. My name is Sivji, and I am the recruitment manager of Canada, but I also help with a lot of engineering roles out here. And I want to just give you guys a little bit of a story. I joined here in October of 2020. And I've seen this company go through an amazing journey, right, of becoming such a data-driven company. And it's not something that just spans within engineering. It goes across the entire organization. And it's really cool to see not only just the development of these teams, but to see our engineers step up to the plate, take on more responsibility. And I'm just so proud of just their evolution and growth throughout SpotHero, and I'm so excited to see what else they can accomplish. With that being said, I want to thank obviously Zach's and everyone who was involved to set up ChiPy at SpotHero. This is our first event of the year, and hopefully it's not the last, right? And we love to see all these faces, and just want to talk about Python, right? And just talk about all the cool stuff that we're doing right now. So thank you everyone, again, who did come out. At this time, I do have to do a little bit of selling. We do have a couple of roles right now within SpotHero from a Python perspective. So if you do actually have any questions, please reach out to me. Please reach out to anyone here who does work at SpotHero. More than happy to talk about it and just talk about our culture, the company. We don't have to get to the nitty-gritty, right? Just find out who we are, and if it resonates with you, we can have further conversations. Just as a reminder, there will be a happy hour after this, and there are drinks in the back. So enjoy yourself, have a good time. Bathrooms for the men are just down there on that side, past that, and on the women on that side. If you do need Wi-Fi, it's just on the wall right there. So please look at that, connect, and just have a great night, right? And enjoy yourself. Take care. And I want to actually bring Mark. Sorry, real quickly, my apologies. Just bringing Mark, the CEO of our company, just for a few words.
All right. Thank you, Sahil. Thank you, everybody, for coming. Really cool to be here. I think my first ChiPy event was 10 or 11 years ago. I wish I would have listened. Caesar knows. We were talking about Python, and now I know a bit more about Python than 10 years ago. And we had a custom framework named Rattlesnake. And everyone said, why would you have a custom framework? We obviously changed that to Django, but that was a lot of horror, and any developer that has ever touched it has said that the Rattlesnake bit them. But we don't have that anymore. And I've learned a lot. I should have listened then. I know that now. But it's just cool to be here, after 10 years and COVID. This is the second in-person event, and happy to host. Thank you, guys.
Awesome, thank you. We have one more quick announcement from a sponsor, which I'll be doing for them. But that is that JFrog, one of our great sponsors, has a monthly raffle with us. So if you are interested in winning a Circuit Python compatible Ada clue that's being given away, we actually have 3 of them being given away. You can scan that QR code now. You can visit that link. We'll toss it in the chat on YouTube for folks who are streaming, but grab it now. Those 3 Adafruit clues will be given away after 2 days. The things will close, and the winners will be announced on Meetup and social media. So I'll give you another 10 seconds, take a snapshot. Awkward silence. All right. So with that, for those of you who don't know and were dragged along today or randomly stumbled upon us on YouTube, we are ChiPy. We are a Chicago Python user group. So we're here in Chicago, for those of you who didn't know, on the internet. We've been around since 2003, and we've grown from pretty humble beginnings of just a few people in a room meeting occasionally, talking about Python, to a 6,000 member strong community. So thank you all for the people in the room and for our strong community. We have a lot of ways to engage with us. So we have a mentorship program. Now you can, that's self-service. So if you're looking for a mentee or mentor on any area of Python, you can check out chipymentor.org. We also have a number of special interest groups that host events besides our main meeting. So the most active recently has been our algorithm SIG. If you're learning to get, looking to get some practice in different algorithms, especially if you're looking for a job, something like that, that's a great place to hone up your skills. We also have Python meetings for those who can't make it in the evenings during the lunch hour, for folks who can do that over lunch. And we also have a great job board. You've heard about some of the job postings from SpotHero. They have a couple posted there. Selfless plug for my own company, Zoro, has some there too. If you're hiring, that job board is open for the community, or if you're looking, check it out. Our next algorithm SIG is on April 7th, and our next main meeting is coming up on the 14th, so we have them every month, usually on Thursdays. I'm also happy to say this is our once-a-year news of a new board. So for those who didn't know, I was our previous chair of the ChiPy board. I am very happily retired now. And big thank you and congratulations to our 2 returning and 1 new board member. Without the board and without our other organizers and without our speakers, you know, we wouldn't be here today. So if you're looking to get involved, get engaged, chat with these people, you can do that via Slack. If you're not already part of the Slack, it's free and easy, automatic and easy to join. You can also engage with us on Twitter or on chipy.org, which for the folks here in person, you know, because that's how you registered to come today. So without further ado, we have 2 fantastic talks scheduled. We're going to learn about the observer pattern from Ali, one of our favorite members of the community. Lots of good talks from him. Check those out on YouTube if you want to see the recordings. And from our host company here today, we have SpotHero, Every Way They Use Python with James Lamb. So without further ado, I'm going to kick this over to Ali. Woo! Technical challenges, hold please.
It's my first in-person talk since March of 2020, so I'm actually a little nervous. It's been a while. Just bear with me while I get stuff set up. All right, cool. So thanks everybody for coming out. ChiPy's back in person. How awesome is that? Woo! Yeah, let's do this. Let me start my timer. All right, so this is a talk I'm going to be giving at Pi Texas in a couple weeks. So it's still a little rough around the edges, so just bear with me and let's just get started. So I'm Ali Sivji. You can find me on Twitter. I am @KayaSivjis. I work at a company called Jasper Health. We are building a patient monitoring solution in the cancer management space. We just closed a huge Series A round, so if you're looking for a job, reach out, we can talk. I'm also one of the organizers of Chicago Python. Not really gonna go into that, Zach's did a great job. All right, so let's just get started. I call this talk Everyday Design Patterns because I really wanted to emphasize that we don't need to be designing complex distributed systems to take advantage of design patterns. We can use them in our everyday code. So here are all the things I'm going to be covering today. I'm not really going to go over this slide, just want to have it up there for folks that want to know what's coming up. So let's start from the top. What is a design pattern? Design patterns are solutions to commonly occurring problems in software design. We can think of design patterns as customizable blueprints that can be used to solve a known problem. And when you use a pattern, you don't use the pattern exactly the way it's described. You sort of adapt it to your specific use case for your project. There are a lot of benefits for using design patterns. First of all, design patterns are tried and tested solutions to commonly occurring problems in software design. Design patterns are not specific to any one domain or application area. Design patterns make our code reusable. We can extract the functionality and use it somewhere else. And finally, design patterns give us a shared vocabulary that we can use with other developers. And this is really, really important. Once we have a shared vocabulary, we can communicate with other developers. Common language allows us to talk about architecture at a higher level versus focusing in on lower level details. I really wouldn't be giving a full picture of the design pattern landscape if I didn't talk about some of the criticisms of design patterns. So design patterns are considered workarounds for the limitations of a programming language. For example, in Java, there is a design pattern to implement features such as multiple inheritance and decorators. We have languages like Python that have these features built into the language themselves. Another issue is once we start relying on design patterns without thinking of the larger picture, it can lead us to design inefficient solutions with a lot of layers of inheritance hierarchy. And finally, when we learn something as programmers, we have a tendency to use that something to solve our problem. Design patterns are great, but they're not a holy grail. You really have to understand how to use them properly. There are hundreds, maybe even thousands of design patterns out there. I feel like a lot of talks go into too many patterns, so I'm going to take it a little bit differently. In this talk, we're just going to cover one pattern. We're going to go very in-depth into the observer pattern and see how we can use this pattern to write loosely coupled components that are easy to understand. The observer pattern, it defines a one-to-many dependency between our objects. If one object changes or performs an action, all of its dependencies will be notified. I think this is best demonstrated with an example. So let's say we have a newsletter that people can subscribe to. Users can subscribe to our newsletter on a weekly, daily, or a weekly and daily frequency. So say user 1 comes along, they subscribe to our newsletter with a weekly frequency. User 2 comes along and they subscribe to the daily and weekly newsletter. And then finally, user 3 subscribes to our daily newsletter. Great, we have 3 active subscriptions or subscribers who are waiting for our messages or waiting for our emails in this case. So the day ends and we have to send out a daily email. Our editors put it together and they hit the send button. We're only going to send it to the people that are subscribed daily. So in this case, it would be user 2 and user 3. And when we send our weekly email, we send it to user 1 and user 2. All this makes sense. The people that subscribe to our newsletter get that newsletter. After a couple months, user 1 realizes they're not actually using the information we provide, so they unsubscribe from our newsletter. Happens all the time, like I do it all the time. So now we have 2 active users. And now the next time we send a weekly email, it's only going to go to user 2 since they're the only active user that subscribed to the weekly email frequency. So this toy example, it demonstrates a few key points. We have a one-to-many relationship. We have one newsletter. We have many subscribers. Subscribers can subscribe to different types of events. We have a daily, a weekly, or a daily and weekly newsletter. When events occur, all subscribers are notified. And optionally, we can include a payload with some extra information that lets the subscriber do whatever they need to. In our case, when we send an email notification, our email body is going to have our actual newsletter. But really, this could be any sort of payload that the subscriber needs to perform its task. And then finally, subscribers can subscribe or unsubscribe to our newsletter. And this can be actually done at any time, even at runtime. We're going to come back to that in a little bit. And I'm just going to say one more thing, that subscribe and unsubscribe is more really depending on business logic. Sometimes we might just want to subscribe, but we don't really have a business use case for unsubscribing. As I mentioned earlier, one of the big benefits of design patterns is to define a common language for more effective communication. So let's take a step back and have this discussion in the domain of design pattern terminology. So we'll go through that definition one more time. The observer pattern defines a one-to-many dependency between objects. If one object changes or performs an action, all of its dependencies will be notified. So going back to that example from earlier, what we really have is we have a single newspaper or newsletter subscriber with a newspaper publisher with many subscribers. Or if we're talking about things in terms of design patterns, we have a single subject with many different observers. And observers can register with the subject to receive notifications. Observers can also unregister, which is the bottom one right there. And then when a subject changes, all of its registered observers are going to get sent a particular notification. So what are some real world use cases of the observer pattern? Note that these use cases I'm going to talk about, they're going to be a little bit more complex. Like there's going to be some software or some hardware that's dedicated to the actual message bus component. But underneath all this complexity, it's just going to be the observer pattern. So the first example is I took a Lyft to get here. When I ordered my Lyft, I was subscribed to all the events for my particular ride. And then when the driver arrived downstairs, they sent a message to the Uber server. The Uber server sent me a notification that my driver was downstairs. Same thing with an Amazon purchase. When you buy something from Amazon, you're going to be subscribed to all of the notifications for that particular order. When something ships, you're going to get an email letting you know that. Pretty much any kind of notification service is modeled with an observer pattern underneath the hood. And the most obvious example would be front-end DOM programming. If we're ever dealing with like HTML, we're adding a lot of event listeners like on mouse over, on mouse load. I don't really do a lot of front-end anymore, so don't really know what those events. I use mouse over is all I know. So now we have a sense of what the observer pattern is and how we can use it. I think this would be a good time to take a look at various open source implementations. When we start digging into open source code or really just other people's code, it helps us understand how other people solve the problem. And hopefully we can use that knowledge to make our code a little bit better. So the first example of the observer pattern I want to talk about is in the Python logger, which is in the standard library. Very quickly, this is like the most quick overview of Python logging I've written. Logger is a singleton. It has one instance. And when we access it globally. When we want to configure a logger object, we have a formatter, which sets what the log looks like. We have a handler, which sets what the log goes to. So we can have like stream handler, which goes to standard out. We can have a file handler that goes to a file. We also have a logger, which assigns handlers to different namespaces. And then when we want to actually initialize a logger, we're going to select it. We're going to select a logger from a namespace using logging.getLogger. So here's an example of configuring a Python logger using a dictionary. Let's walk through this really quickly. So at the top, we have a formatter called standard. It's just setting some of our log fields, setting our date format. We're going to set up two handlers. The first handler is going to log to a file called stam.log, and it's going to log everything using the format, the standard format, with a level of debug and higher. The second handler, it's only going to log error logs and critical logs to standard error, sorry. And finally, we're going to create a logger in the root namespace for these two handlers. And this logger is going to be triggered when the level is debug or higher. Or said another way, we are registering handlers to a logger in the root namespace. And the logger is going to receive log events that are debug and higher. And just to note that if we don't specify a key inside this configuration, it's going to put it into the root namespace. I'm pretty sure that's the way I've been using it. So now we can import our logger, load our configuration, and fetch a logger. And then we'll just have some lines to log inside of our application. So when we look at the file logger, it looks like we got all those 5 logs that we specified. But if we look at the error to console handler, we only got the ones that are error and critical. So going back to the observer pattern, we have a one-to-many relationship. We have one log event that can be processed by many different handlers. And just review of the logging workflow, we register handlers with a logger object. the application has log statements, which produces a log record event. The log record is passed to all of our handlers, and if the handler matches and it has a level of the log being equal or greater than the handler, we're going to emit a log. Otherwise, we're going to ignore it and pretend like nothing ever happened. Another example of observer pattern in open source software is found in Flask. Just an overview of Flask routing. Flask is a web framework, for those that don't know, that routes client requests to different handler functions. This is the canonical example we always find in the Flask quick start. I think this is the reason most people use Flask. Like, it looks very easy to use, hides a lot of that complexity. So what we can do is we can use decorators to register our view functions for different URLs. So we have the app.route decorator for / going to our index handler, and then we have a login handler function that goes to the / login route. And as Flask runs and builds out its just like application underneath the hood, and as it registers events, it's going to start building a routing table. And here's the routing table that we're building for this particular web app. And so when Flask gets a web request, it's going to use its internal routing table, and it's going to send that request to the appropriate handler. And going back into the observer pattern domain, we have a one-to-many relationship again. We have one router or one request, and then we have many different route handler functions. And just the way routing works behind the scenes, we can add a URL rule using one of Flask's helpers. And this URL rule is going to be unique for each path verb. So it's going to be unique for like whatever the path of the request is, as well as the HTTP verb. This is sort of a business rule that we encode into our observer pattern. When the handler is registered, it is updating our underlying routing object. And then when a request comes in, it's going to forward that request to the appropriate handler. And then our handler function is going to do whatever it does and send a response back to our clients. Another place we can use the observer pattern is PyTest plugins. So PyTest plugins are built on top of a hook-based plugin system. And what a hook does is it identifies different points in your application where the application can be extended. So when PyTest first loads up, what it does is it loads all of our plugins, and it registers those plugins for various hooks. And then when a hook is triggered as PyTest is going through its runtime, all of the registered functions for a particular hook are going to be notified. And in PyTest, the functions are actually provided with a payload, and they can modify that payload and pass that payload back as they choose. And a fun fact, PyTest doesn't really have a lot of logic. It's actually built on top of a plugin system called Pluggy. And so all of PyTest's core functionality is implemented like a plugin, which I think is pretty cool. So this is the observer pattern on like steroids. So what kind of hooks does PyTest have? There's hooks for many different types of categories. So the hook that I'm going to be walking through is writing a simple PyTest plugin. What that's going to do is it's going to, where's my mouse? There it is. Actually, it's not there. Okay, so I'm just going to point. Here what we're going to do is we're going to add a ~fast keyword, and we're going to write up some code to handle that with a PyTest plugin. So the first way to do this, so the first thing we have to do when we do this is we have to call on the PyTest _add option hook, and that's going to allow us to add command line options when we run PyTest. And then next, we have to also use the collection modified items hook, and this is the hook that runs when PyTest is doing test discovery, when it's going through all your folders to find all your tests. And in this plugin, what we're going to do is we're going to check to see if a flag exists. And if it does exist, we're going to add that to our list of tests that we actually need to run. That way, when we actually have the ~fast, it's only going to run all of our tests that are marked as fast. So how does this relate to the observer pattern? Again, it's a one-to-many relationship. We're going to be seeing this quite a bit. We have one plugin manager, many different types of plugins. And the way PyTest works is when PyTest first loads, all the plugins are loaded and registered. And then as PyTest runs, hooks are triggered, and the functions that are registered for these particular hooks, they're called and passed a specific payload. And the last implementation I'm going to be talking about is the observer pattern, which is built into Node.js. And this is actually how I first learned about the observer pattern. I saw somebody using an event emitter, and I wanted to port it to Python since it seemed like a really cool workflow. An overview of the event emitter. So just first of all, if you don't know, Node.js is a JavaScript runtime that allows us to run JavaScript code outside of a browser. And inside of a browser, we can handle user interactions with event listeners. With Node and the event emitter, we can use that same design principles to handle events inside of backend Node code. Let's check my time. Looking good. So I think the easiest way to understand the event emitter is with an example. So we're going to import event emitter. We'll create a new instance. And next, we're going to register 3 event handlers. 2 of them are going to be sent a start event. And then they're also going to be passed some callback functions. So that's sort of just the syntax you see up there. And then finally, we're going to just emit the event for start. And then when we run this script inside of a Node runtime, we can see that the script only ran the callbacks for the 2 events that it cares about. It didn't do anything for stop. And so relating things back to the observer pattern, again, we see a one-to-many relationship. There is one event. There are many different event handlers. The event emitter workflow is creating an instance of the emitter, registering all of our callbacks for a given event type. And then finally, when the event occurs, all those callbacks are going to be executed. And I wanted to make everybody aware of a Python port of the event emitter. It's called PyEE. It's a decorator-based event emitter. And you can actually plug this into an async or trio or curio event loop, which I think is pretty cool. So if you wanted to use like async, I think the event emitter is a really good pattern to take advantage of. And so looking at all these open source implementations, we did see some common themes. There's that one-to-many relationship. I think I said it like 4 times. Every time we're running our script or running our application, we're registering events with a handler. And then when an event is triggered, all those handlers or maybe just that one handler are going to be called. And I really wanted to use all these examples to illustrate that the observer pattern is not a one-size-fits-all solution. Each implementation is solving a different type of problem. And as you saw in the Flask example, we can actually codify business rules inside of our implementation, which is pretty awesome. So that's a lot of theory that we talked about. So let's roll up our sleeves, write some code. And so for this example, I'm going to be implementing a Slack bot using the observer pattern. And so really quickly, if you don't know, Slack is a chat platform. We can use the Slack API to build applications or bots that we can interact with, that we can use to interact with users or to automate different kinds of workflows. So the one example that I'm going to be focusing in on is the slash command. So with the slash command, we can allow users to invoke our application by typing in a string into the message box. And so the way the slash command works behind the scenes is it's going to cause, when we send a command to Slack, it's going to cause Slack to send a payload to a webhook associated with this bot or with this application. And then the application is going to do whatever it needs to and return a response back to Slack. So going back to our command, clicking that send button, it's actually going to send this particular HTTP request sort of formatted the way that it's going to be sent across the wire. Maybe not exactly, it's not binary or anything, it's still like text. So it's going to be a post request. It's going to go to our slack, I should name this a lot better.
10 times fast.
Yeah. Y'all can read it. I'm not going to do this. It's a little tongue twister. My first time in a while. All right, so this request is going to have, it's going to be a post request. and the body is encoded with form, it's all form encoded. And in that payload, all the data that were sent, it's really not necessary for what we're trying to do. There's a lot of metadata. So things that we really care about are the command and the text fields. And so building out our MVP, we can use Flask to handle our slash commands. We can also create a Slack bot that responds to the slash observer invocation. And the things that we really care about is when we do slash observer time, we want to return time, slash observer date will return date. And then we can use the slash echo and whatever text we want to use, and it's going to echo that back. So the first time we're going to be implementing this, like let's just hack things together and keep it simple. We're going to do everything inside of one particular function. So this is just some Flask boilerplate to handle a new request. We're going to pass our request body that we just talked about. And now we can write up a conditional to handle each of the subcommands that we want to handle. And I think this is a really good start. By inlining the initial solution, we can get things up and going really quickly, and iterating is like the most important thing. You want to have something you can show to other people. But as our program grows and as we start to handle more commands, or as our handler logic gets more complicated, you can start to see how this inline approach is going to get a little bit messy. And if we ever find ourselves writing a series of complex if-else conditionals, it indicates that there might be a better way of doing it. It doesn't mean we have to actually go out and refactor our code, but it's just something to keep in the back of your head. I believe a wise man once said, if statements are a code spell. That was me, by the way. And since this talk is about the observer pattern, let's refactor our Slack bot, and we'll have it use the observer patterns, specifically a decorator-based event emitter. So before we do that, like why is the observer pattern the one we should be using? We have that one-to-many relationship. That's sort of like the key I want to emphasize. Here we have one slash command, and we have many different command handlers. We're going to be registering our command handlers with a particular command. And here we only need to register command handlers. We don't need to unregister. And a business rule I'm going to specify is each command is going to have one and only one handler function. And then once we get a command, it's going to be handled by our handler function. It's going to execute something and send that back to our Slack instance. So going back to the code, we're going to have some Flask boilerplate. The first refactor we're going to do is we're going to take all of our command handlers and we're going to move them into their own functions. I think that's a good start. Next, we're going to create an instance of the event emitter, and then we're going to use decorators to register handlers for all of our various commands. And then finally, we have to have some logic inside of our view function to connect some dots in terms of parsing our request and then emitting the event. And I just want folks to notice one thing. We have a default keyword in that return statement. If we find a command, or if we enter a command that does not exist, it's going to go to our unknown handler, which is going to return something like this command is not known. And this event emitter, I actually did not use PyPI. I implemented my own event emitter since it wasn't really complex. Like I think this is 17 or 20 lines. And it also enabled me to hard code some business logic. In my case, I only want to have one event handler per event. So you can see that if we add more than one event handler, it's going to raise an exception. All this code is going to be on GitHub. I'm not going to walk through it, but it's all available for later on. So let's take some time and think about like, what do we do here? Like what happened in this case study? So I'm going to be the first one to admit, this implementation that I refactored to was a lot more complicated, but we really need to start thinking about the cost benefit of adding this increased complexity. Your laptop is done, by the way. So what are some of the benefits of using this pattern? We're thinking about this cost benefit. The main thing is we're going to decouple our event parsing and our event handling logic. And I did want to emphasize that we did implement the observer pattern with functions. Traditionally, when you see observer pattern referred to in books or on the internet, you're going to see a more object-oriented approach. I do have links to other approaches, but I went with functions just because functions are a lot easier to understand than classes, and decorators provide a great interface to allow us to register something with a function at runtime. Functions are awesome. We have an input, we do something, we have an output. There's no mutable state, don't have to worry about anything. I did want to make spend some time on the observer pattern versus PubSub. A lot of people probably use PubSub maybe at work, designing some event-driven systems. So again, this was our high-level diagram of the observer pattern. We have one subject, many different observers. This is a diagram for PubSub. We have one publisher, many different subscribers, and in the middle we have a broker. And this broker is going to handle a lot of our message routing. So when a publisher first starts up, it's going to tell the broker, I am writing events to a particular channel or to a particular stream. And then when a subscriber starts up, it's going to talk to the broker, and the broker is going to know what message streams or what channels the handlers are subscribed to. And the broker is going to also have things like, did this message get sent? Do we have to replay these messages? So there's going to be a lot of complexity. But underneath the hood, it really is the observer pattern. So that's pretty much about it, sort of a first run through of this talk I put together. I do have some resources I did want to share. The first book is called Head First Design Patterns. It's a fantastic book if you're wanting to learn about design patterns. And the second one is the famous Gang of Four book. It's more of a reference book. We don't really use it to learn, but it's really good to have on your desk if you want to look something up. Yeah, that's it for me. Thanks so much for your time. Do want to give a shout out to ChiPy. We're back in person again. Very excited. Yeah. Does anybody have any questions? Yes?
I was thinking about, didn't you implement the observer pattern by just having a dictionary? Didn't you implement the observer pattern by just having a dictionary and having the different values that determine like different behavior as a key? Just pass the key and then have a function in the dictionary and just execute that function?
Yeah, sure. The question was for the online stream, are we allowed to use the observer pattern with a dictionary where the keys are the events and the values are what we want to call? Definitely. Like, I think that method is called dictionary dispatch in Python. You can definitely like do that behind the scenes. And if I go to my implementation of the event emitter, you can see here I have a dictionary in my init called registered events. So I'm pretty much doing exactly the same thing. Yeah, great question. Anybody else? Awesome. Thanks, everybody.
We have one more great talk for you tonight, but we're going to take a quick break. So if folks want to grab some more pizza, some drinks, now's the time. For folks on the stream, we will come back in just over 10 minutes. So we'll come back at 7:25 Central.
All right. Yeah, thank you all so much for coming out. Thank you for the introduction. So my name is James Lamb. I'm a machine learning engineer here at SpotHero. You may have seen me around GitHub. If you do data science and data engineering in Python, you'll see my little carefully crafted South Park Studios emoji of myself out there. It actually goes slightly beyond prefect, et cetera, et cetera. And I want to take a moment to brag to this group. I am the reason that when you pip install pandas, you no longer are downloading PowerPoint files to your laptop. So just saying. All right. Cool. So yes. This talk is called Every Way SpotHero Uses Python. So at SpotHero we use GitHub for source control management. So when I put this talk together a month ago, last night, I went into GitHub and I literally searched for every file in SpotHero's code base that ends in .py. And I want to summarize them for you today. So the goal of this talk is to sort of broaden your imaginations of what Python can do. And to sort of ground it in, I'm not talking about like side projects or stuff. This is all stuff that really powers SpotHero's operations, sort of how this business runs. Hope it's going to be fun. Okay. Does James know how to work Google Slides? Oh, yeah. So first, let me tell you a little bit about SpotHero, just so you sort of have a frame of reference for all the other things that I'm going to tell you about. So SpotHero allows you to search for parking and reserve it ahead of time. It's really sweet. In fact, you could all take out your phones right now and book a parking spot. All right, well, that didn't get enough laughter or enough spots to book. That was brutal. That's okay. So SpotHero allows you to search for parking and reserve it ahead of time. It's really sweet. I'm going to be using it this weekend when I go see Hades Town. So SpotHero, one of the reasons that SpotHero is really valuable is that the marketplace of sort of how you book and pay for parking and how you get into a parking spot is really complicated, right? And I'm sure that those of you who drive have experienced this. There's a lot of different ways to get into spots, different ways to pay. With SpotHero, you just sort of go into this mobile app, you pay us money, you book ahead of time, and then we just sort of give you this really nicely formatted parking pass that tells you, here's how you're going to get in, here's how you're going to pay, and you're going to have a great time. So that's what SpotHero does. Okay, that's all about SpotHero. Let's talk about Python code. So first and foremost, let's just get right out with it. Mark mentioned this in his introduction. SpotHero's core services are written in Python. Okay, folks, when you click buttons in the SpotHero app, which I know you're all going to do tonight, you are making code run in a large Django app. Full stop. And so we do a lot of sort of the core things of SpotHero's business in Python. And that's like managing the details of parking facilities. That's like processing payments, including through third-party services like PayPal and Stripe. That is generating QR codes. Did you all know that there's a library in Python called QR code for generating QR codes? I learned that last night. Really cool. We use Python to send push notifications to your mobile app. So if you're using the SpotHero mobile app, you might be getting push notifications triggered by Python code, and so much more. For each of these sort of sets of applications, I also wanted to give you a representative sample of the libraries that are involved here, so you can kind of get a sense of what is the flavor of what's going on here. There's many more. I'm happy to take questions about this after, and really glad that Caesar is here to correct me on some of the stuff that I haven't been exposed to in my less than a year working at this company. Another way that we use Python a lot at SpotHero is in writing command line interfaces. So when we get to sort of common tasks that are a little bit more complicated than we're comfortable putting into, say, a makefile or a gnarly shell script, often at SpotHero, we turn to Python for writing CLIs. And that's for a bunch of stuff. For example, we run, so I'm a member of the data engineering team here at SpotHero. We run Apache Airflow and Kubernetes, and we've been trying to push teams that use our Airflow system to use something called the Airflow Kubernetes pod operator. It's really sweet if you've never seen it. Basically, every task in an Airflow pipeline becomes a Kubernetes pod. There is a ton of boilerplate involved in setting up these jobs. You have to basically generate sort of a Docker file, your sort of Python module with your logic of your task, your Airflow DAG, a config for the CI system that sort of deploys your stuff. We wrote a CLI to sort of scaffold all that out and keep it connected. Another thing that we do on the data engineering team, we run some services that are used for sort of executing queries over files. That's like AWS Glue or the Hive Metastore. And often you have to find yourself doing this metadata surgery, saying, hey, Hive, please look in this other place in S3 for these files. We wrote a CLI for that. We wrote a CLI in SpotHero for bulk issuing refunds to customers. So occasionally we find in SpotHero that maybe customers are targeted by, maybe they are targeted by some sort of fraud, or maybe there's some sort of mistake in our application logic that requires us to issue refunds to a bunch of customers, right? We have a CLI for that. We have a CLI for manually clearing the history in the Apache Airflow system. This is really useful when we need to backfill data products. We use a set of CLIs for scraping data lineage information into an open source data catalog called Datahub that we run here at SpotHero. If you haven't seen Datahub, this is a project that came out of LinkedIn. It used to be called Warehouse, spelled H-O-W-S at the end. And this is really sick. by data lineage, what I mean is we run this service at SpotHero where you can say, hey, given this table that I've been querying, what was the job that produced it? What were the tables that that job consumed, et cetera, et cetera, et cetera, and going the other direction, right? If I remove a column from this table, what other jobs will be broken? What other tables will be broken? We do that with Python. And of course we use, I shouldn't say of course, we use Alembic for generating database migration code. It's really, really sweet. And I hope you'll also notice in the libraries here that we have argparse, click, and config parser. All are welcome. All are welcome. Another place that we use Python is in Sidecar Containers. So a lot of our applications at SpotHero are deployed in Kubernetes. And for those of you who are familiar with Kubernetes, the sort of like main unit of work is something called a pod, which is a collection of one or more processes wrapped in containers that are doing stuff. By sidecar, I mean sort of things that are not doing the main application logic, but that are doing some sort of other administrative function. A really, really common application that we have here is using a service called Kafka Connect. Kafka Connect is an open source set of connectors. You can think of this as like an open source alternative to something like StreamSets, Apache NiFi, Fivetran, something like that. I mean, Apache NiFi is open source, fair enough. But and what this does is you basically say, hey, Kafka Connect, I have data over here. I have Kafka over there. Make the data show up with Kafka. Even though those Kafka Connect connectors are written in, I don't know, some kind of JVM thing, Java, Scala, Kotlin, whatever, I'm not sure. I know you need Gradle to build it. We actually use a Python project to expose health checks over those instances. Kind of cool. Another place that we use Python at SpotHero is for custom checks and continuous integration. If I can just, it didn't bring my soapbox, but just imagine that I brought it. If I can just get up on the soapbox for a second, I am a really, really big believer in teams reflecting their team agreements into their continuous integration pipelines. If you say we all agree that we're going to use like this particular docstring style, or we all agree that every external link in documentation should always be live, we should never have dead links, you should be putting that into your continuous integration, et cetera, et cetera, et cetera. We have sort of like team agreements like that at SpotHero at different integration points where teams sort of are working together on code. And one of the ways that we enforce those is through custom, just like kind of gnarly Python scripts that run in continuous integration. For example, we have a gRPC service that's written in Kotlin, so there's no Python involved in the business logic of this service at all. But that service is actually using Python to orchestrate a bunch of calls to other services in their integration tests, because they found that Python allowed them to more quickly sort of iterate on creating those integration tests. As another example, we have a service on the data engineering team that is like a run SQL on a schedule type of service. Basically, you check a config into a GitHub repo, and it has some SQL, a cron schedule, and like some other stuff. And some other code somewhere else, code generates an Airflow DAG based on that config. Well, to make sure that the data engineering team isn't, sort of required to provide like very lengthy reviews on every one of those contributions, we just have random gnarly Python scripts that run and validate that the config values in those configs are sort of valid values. As another example, we use a vendor here at SpotHero to track sort of user interactions in our application. So every company that distributes a mobile application has something like this, right? You click login, an event goes somewhere, right? You click purchase, an event goes somewhere. You update your, I don't know, in SpotHero app, like you update your preferred vehicle, some event gets logged that says you did that, right? We have this really interesting thing where mobile app developers, they're sort of defining schemas for those events. Those schemas are enforced on read, not write. They're specified in JSON schema. And then on the data engineering team, we have a bunch of ETL jobs that process all that event data and flatten it back out into something you can write SQL against. To make sure that we're sort of like only publishing data that actually has these schemas, and that the schemas don't sort of have issues, like problems that will cause issues for those that downstream processing, we wrote a bunch of gnarly Python scripts. For example, let me tell you a horror story. I was alerted when I was on call about 2 months ago for one of these downstream jobs breaking. And that was because someone, one of our mobile developers, introduced one of these schemas for an event, a new type of event captured in our mobile app. I think it was called like gates not opening or something, apostrophe S. And guess what? When we tried to turn that thing into the name of a table in Hive, no apostrophes allowed, folks. So that's where we use Python to sort of enforce those constraints and sort of like in those places where we maybe need to go a little bit further than make files or shell scripts. Yes, we have a question up front.
So you can't have RM, RF / as a name?
So the question was, you cannot use RM, RF as a name in this service. No, we're never executing any of this stuff as code, but great question. What would you have said if I said, oh yeah, we just exec it, right? We just eval it right through and like let people do it after. Thank you for that. One library I want to point out, another one that I learned about creating this talk is this library called TypeGuard. I actually had never used this before. So many of you may be familiar with MyPy. MyPy is a type checker for Python that you can think of as sort of like a compile time or build time type checker, right? Similar to the way that TypeScript works. TypeGuard is a runtime type checker. So this is like sort of eliminating some of the boilerplate and checking the types of data passed into functions, similar to what people use like Marshmallow or Pydantic or adders, catters, stuff like that. I just had never heard of TypeGuard. Okay, let's take a wholesome meme break. Thank you so much, everyone who laughed. I really appreciate that. I worked really hard on this on Meme Generator. Okay, how else do we use Python at SpotHero? So at SpotHero, we end up ingesting a bunch of data from other services, data not generated by our applications. We use Python for that. So for example, one of like the really compelling features of SpotHero is the ability to book parking for an event, right? Like I'm going to I don't know, let's say Boston Red Sox game and I want to park there. We end up ingesting event data from sort of like ticket sellers and other sources of that information. We use Python for that. We use Python to ingest data from our sort of customer support automation systems so that we can understand, like we can build out some reporting around how quickly customer calls are getting answered, the load on our customer heroes, et cetera, et cetera. We use Python to ingest clickstream data. That's like basically just like big blobs of flaming JSON about things that people do in our apps. We use pandas to like sort of flatten that out. We use Apache Airflow heavily to do like custom processing on that. And one of the really cool ones is we use a bunch of the, I should have put them on the library list. We use a bunch of the geospatial libraries in Python, like Shapely and GeoPandas and what's that one with the name from Shrek? Fiona. To do a bunch of like processing of geospatial data. So for example, whenever you're sort of like logged into the SpotHero app and maybe you're booking a spot at a location, that location has GPS coordinates. It might have a street address. One of the things that we do sort of in like data processing offline is take shape files defining neighborhoods and cities and perform a spatial join on those GPS coordinates so we can say, oh, here's all of the rentals that happen in Lakeview or Bronzeville or wherever. Lots of cool stuff in Python. Okay, another one of the places where we use Python a lot, and I think that this is one of the main places that Python shows up in companies, maybe Ruby, but I think Python, is in what I'm going to call glue code. And this is just generically like those things that are not exactly libraries, they're not exactly services, but they're just sort of like the code that has to run to make the things fit together. For example, one of the things that we do is aggregate some customer data, some sort of like historical data about customers' interactions with SpotHero, and publish that into our CRM system so that our customer heroes, when they're taking support calls, they can get a quick summary of, is this person someone who uses SpotHero a lot? Are they going to need a little bit more guidance, et cetera, et cetera. As another example, we use Python code to trigger execution in other execution frameworks. For example, we use Databricks at SpotHero to create on-demand Spark clusters to sort of say like, okay, spin up a Spark cluster, do a bunch of processing, write the data somewhere, and spin it down. Well, we use Python to trigger all of that, just like making calls to the Databricks API. We use Mandrill and a couple of other sort of like email-y packages in Python to send internal emails. So remember I talked about those sort of like schemas on clickstream data, right? We use Python to generate emails to our mobile developers to say, hey, you're publishing data that doesn't match any known schemas, we don't know how to parse it. We use Python code to publish custom metrics to the system that we use to monitor all of our applications. That's Prometheus. And we even use Python to process payments, through vendors like Stripe and through our other sort of payment processing services. So we're using Python in a lot of fun ways. Let's do the obligatory XKCD slide. We have a bunch of stuff, like every company that's been running Python for more than a year that is like somebody thanklessly created some, I don't know, today I was working with this project called HMS Client. It is a Python client for the Hive Metastore. Last commit, June 2018. We have stuff like that. It's okay, it's fine, it's all fun. It's called job security, folks, job security.
I think that package is called curl.
You said you think that package is called curl? No, curl is extremely well maintained, and you should follow its maintainer on Twitter. He's great. Okay, anyway, we use Python for sort of extracting, transforming, loading data, and for data processing. And this is where there's like really, really heavy usage of Python and SpotHero. So for example, that clickstream data I've been talking about, that shows up as gzipped. I'm just going to say a bunch of tech words at you, just everybody smile now. That shows up as gzipped JSON data in something like S3. And we're using Python to flatten that data out, read it out of S3, write it into a columnar store like Parquet, and maybe tell a metastore like Hive or Glue about that data. We're using Python to do this sort of spatial join that I talked about before. We use Python to take that clickstream data and apply some logic to sessionize it, to say like, we have this stream of things you did in the SpotHero app. Well, let's say like, how are you going to bucket that into sessions, or like a contiguous period of time spent doing stuff in SpotHero? We use Python to read from and write to Kafka, okay? Don't believe anyone who says that every Kafka app has to be in a JVM language. Not true. Kafka Python project is great. And we even use sort of Python to generate aggregations of our data for use in advertisements. So for example, if you're ever sort of searching for parking and you see an ad from SpotHero that says something like, parking near Soldier Field tends to be between this and this amount per hour, that was some like crusty Python code that someone in my team wrote to populate those numbers and make them show up in the search engine that you're using. And you can see the diversity of libraries here, right? Like clients for AWS, Airflow, clients for databases, PyArrow, all kinds of fun stuff. I only use Python for machine learning model training and scoring. All machine learning work at SpotHero is done in Python, full stop. I think it's been one of the interesting things, joining here as a machine learning engineer. We have such a small data engineering team and such a small data science team compared to maybe like other companies that I've worked at, that we can tolerate these sort of like team agreements of, we're just doing Python. We're not spending any time and attention on supporting R or Julia or like, there is a TensorFlow.js, but like, why? And we use a bunch of Python projects for a bunch of different applications. We're using Python, sort of to predict customer churn so that we can spend our limited marketing budget targeting customers that are likely to respond to our advertisements. We have some services at SpotHero that dynamically set prices based on demand, and we're using things like Profit, LightGBM, and XGBoost for forecasting the demand for parking, forecasting the availability of parking, for setting prices, et cetera, et cetera. And this is sort of all of the standard like machine learning stuff that you probably expect to see. It's all in Python, folks. We also use Python for data visualization. So we have some sort of like managed no-code or low-code services for data visualization at SpotHero. We use Looker, we use Amazon QuickSight. I would guess if I looked around closely enough, there's probably some Tableau somewhere. There's lots of Microsoft Excel. But for some things that teams work on, they need Python. They need the power of Python. For example, like when you're working with sort of like larger scale map data and putting sort of geospatial point data on that, these libraries like Folium, Looflet, GeoPandas, amazing. When you want to sort of automate the generation of a lot of plots about, say, descriptive statistics on features for a machine learning model, Matplotlib, Seaborn, Plotly, these things are awesome. And like every company, we just have a bunch of like miscellaneous plots. And Python is a great place to do that type of work. Okay. I just have one more application of Python to show you all. But I want to be sure that everyone is emotionally prepared for this. If you are squeamish about unnatural applications of Python, this is the time to leave the room. Did you all know that you can run Python as a user-defined function in Redshift? Did you all know that? Look at that. We do that. It's awesome. You can write Python code in this SQL dialect called PLPY-thonu. I don't know how to pronounce that. I don't know, I'm not even gonna try. But yeah, you can run Python in Redshift. There's a link to the docs here in AWS. It doesn't even have to be sort of like self-contained little lambdas like that. You can write deeply nested custom modules with like init.pys and all kinds of like fancy imports and indirection, all kinds of stuff. And you can register that in Redshift and then call it from SQL. Are you all ready for the kicker? Only supports Python 2.7. Okay, and with that, thank you so much for coming. I really appreciate your attention and your great questions so far. What questions can I answer for you?
So I'm actually kind of curious with the GeoJSON, like, how do you actually like the GeoJSON basically maybe with latitude and longitude defines basically, let's say you define like a shape and everything in that. How do you then search like whatever's in that shape into a database? Like I can see if it's a convex polygon, you could easily just take the min and max. But what if it's not a convex polygon? What if it's a concave polygon?
Okay, cool. So the question was, if you have geospatial data and you're trying to join that to polygons, like I talked about, right? You have definitions of something like a neighborhood or something. How does that actually work in Python? So as you'd expect, the answer to how this works in Python is it calls a bunch of C code. And let me tell you about that. There are these really like battle-hardened geospatial libraries like libgeos and libgdal that define these common operations for doing things like a spatial join. Doing things like, given this description of a geometry, is this description of a point inside, on the border of, or outside this geometry? The packages that are available in Python, like Shapely, GeoPandas, Fiona, those are all tapping into those C libraries. Does that answer your question?
Yeah.
Cool. We are not like re-implementing all that like geometry and trigonometry from scratch. It's just a Python library.
You're basically having a Python language that says, given this shape, in this shape are these points.
Yes, so there are these Python libraries. If you are interested in working with geospatial data and didn't think Python was right for it, I really recommend checking out Shapely. It sort of has like first-class support for these different types of objects that are the primitives across every geospatial processing application. They're the same primitives you'll see in R, in RD, in like RGDAL, in SF, and SP. They're the same things you'll see in PostGIS. If you've never heard of PostGIS, this is a plugin for Postgres that allows you to have columns of polygons and line strings, and to join polygons to point data in just SQL. It's really, really cool. They're all using those same underlying C libraries. Are there any other questions that I can answer? Right here.
Of the libraries that you listed or additional ones, what's your favorite or you find most useful?
Oh, wow. Of the libraries that I listed, what is the one that I find most useful? I want to say LightGPM because I'm a maintainer on it, but I shouldn't. That would be bad. That's a great question. I actually love requests. I love everything about requests. I think it is so powerful, but so straightforward. Like, I feel that I understood requests pretty well after an hour of looking at it. And I'm like not that smart, okay? That's not like me bragging about that. I just think it is so well designed, it's such good encapsulation. And And it's one of the few things that I learned when I first started learning Python that is still like the new hotness today. That's still the standard. What other questions do we have? Back here.
So let's say the Bulls are playing against the Lakers. I want to know by how much the pricing for parking goes up and how do you define it? Like, is there like a calculation behind the scenes that the Lakers are playing bad this season, so the parking price is going down?
So the question was, the Bulls are playing the Lakers. They have sort of different fates. The Lakers have been kind of struggling on the border of that play-in game. How do we price parking for an event like that? Mark, do you want to answer that? Come on. You all know I'm just a back-end engineer, right? Like I don't do all that.
I love how he's kicking it to me about how pricing works, but actually, you like are involved in the matrix model, which I don't know if we want to get into all of that, but we've got the largest data set of demand. We know where people are searching, how they're searching, what their past stuff was, obviously all anonymized, right? So whether the Lakers are good or bad, it's reflected. We don't search that, but we know what people are willing to pay based off of behavior, past and present. And so there's machine learning models that take into account a lot of different variables. So sometimes the Lakers could be very bad, but people are willing to pay more for whatever reason. And sometimes the Lakers can be really good, and people are willing to pay less for parking. So that might be statistically significant, it might not.
Great answer. Thank you. I will just add, I remember a time in like the Ben Gordon years of the Bulls when the ads on WGN were only about who the Bulls were playing. Like, come see Kobe thrash the Bulls. So I just want to add, I remember that period. Okay, what other questions? Right here, can we pass the mic? What do you think?
Does SpotHero use async Python in any way?
Does SpotHero use async Python? You know what would be great to answer that? Caesar.
Not much yet. Yeah, there definitely some places for it. I'd like to see a little bit more of it, at least in my side of things. On the data, I don't know if y'all are using async much.
Almost everything that we do on the data engineering, machine learning engineering side is synchronous. Like it's kind of by design.
Yeah. So yeah. For most things that you would think you use async for, we end up using salary. Which tends to fit it, like just send it off somewhere else so that there's an issue with it, it doesn't break anything in line.
Yeah, that's a great point. There's in several applications at SpotHero, that's sort of the way that we're achieving asynchronous execution is having a queue of tasks and a separate bank of workers that pick up tasks out of that queue instead of like an asynchronous sort of like thread in Python. Great question. What other questions can we answer? Can we SpotHero people answer? In the back.
Is there anywhere that you've replaced Python with a lower level language or gone the other way, replace the lower level language with Python?
Oh, that's a great question for Caesar.
Yes, actually, we have some pieces of our pricing which have been replaced with lower level language Go in your case. Going the other way around, I'm not sure, I don't think so. But we've mostly just stuck with Python for a lot of things and haven't really had a reason to go out with it, except for like when we want something like really, really fast. But and like, put it this way, like really, really fast means like really fast. The monolith, the big piece of software handles millions of customers. So it's fast enough for the vast majority of use cases.
Yeah, for sure. Great question. Thank you. What other questions?
We'll take just one more question, and then I think we can save it for after.
Sounds great.
Last question here.
Sure.
I was just wondering, what is the most favorite sub method in Python?
What is the most favorite pub sub method in Python? I don't know that I am qualified to answer that question. For the sort of like applications where you need a message bus and we're sort of like separating producers from consumers. At SpotHero, we use Apache Kafka for that. I think that's popular with a lot of companies. We also use Celery in a couple places like Steve and I were talking about. In terms of sort of like Python libraries where you're setting up publisher, subscriber, and broker all in Python, I don't have a personal preference between like RabbitMQ or MQTT or whatever other thing. I'm not sure if any of the other SpotHero people do. No, there's lots of cool stuff out there.
Big round of applause for James.
Thank you all very much.
So thank you everybody for joining us in person online. That concludes the talks, but I think we have some food, we have some drinks, a lot of people here. Good time to network, chat, talk about the stuff. I think James, if you'll be around, I think there might have been a couple other questions. Feel free to ask. I will post these slides in the ChiPy Slack, so if you're not a member, go to chipy.org. You'll find a link there so that you can join and you can get the slide decks from this evening. Thanks everybody for joining us.
Yeah, I was